Everyone, so just a disclaimer, this video starts out slow, monotone, and boring, but I'm amped up right now because of the way this video went. I feel like you guys are going to get a lot out of it. So if you can make it through the boring first 2 to 4 minutes, I think you're going to be really happy that you stayed tuned and watched it all the way through. Don't forget, if you do like this video, by the time it's done, please like the video, subscribe to the YouTube channel if you're on YouTube, all the above. I would love to hear your guys' feedback. I note that at the end of the video, but just telling you right off the bat, I think you're going to really enjoy this one. So please enjoy. Hey everyone, let's start out this video with a beautiful 360 view of this implant design. And you could see these turned out amazing. Implants were placed pretty well, and we left the margin subgingival all the way around. These are going to look great. Now, I want to make a video kind of explaining how to get these results with the implants. There may be some of you out there who are novice users and don't quite understand implants, or you're not ready to tackle implants, but CEREC has made this system so easy, so user-friendly. If you just open up your mind to it and watch this video, I think you may find them very achievable. So with that being said, this is the outcome of what we did earlier today. And when starting any implant case, you're gonna start in administration, and first things first, you're gonna want to make sure you've got everything dialed in here. Now, this is in lab, so things may look similar to you, they may not, but they're pretty much the exact same. The in-lab software and the software that you're using, the CEREC software, pretty much the same thing. Everything that we check, everything that we do in this phase is going to be the exact same in CEREC. Layout is a little bit different, and the color scheme is a little bit different. But when you're in the CEREC software and you're in the administration phase, the first thing that you're going to do is click multi-layer. I hardly ever leave it at screw retained. When you leave it at screw retained and you go into the design phase, and say you get your design exactly where you want it, but you don't like where the screw access hole is, you have no option to split that. So you then have to go back, check multi-layer, the software is going to repropose your design, and you're going to have to start from scratch just to get a split crown, meaning an abutment with a overlay on it, a crown over the abutment. So always start with multi-layer, because even if you don't want a multi-layer crown or split crown, you can still finish your design and go into the export or manufacture phase and mill it as a screw retained crown, even though you checked multi-layer. So to me, it makes no sense that they even offer the screw retained option. It should just be left as multi-layer, because when you check it as multi-layer, again, you have options. So first and foremost, always check multi-layer. That's my advice. That's what I do. And that's what I would do if I were you. But let's carry on. Secondly, you're going to want to ensure that you've checked the right implant. And usually when you're sending out a case to whether you're having it designed, you're having the lab completed all the way through, and they're using the in-lab software, you always want to make sure to indicate the correct implant before sending that out, because that will carry over through Sirona Connect, and usually on the lab end of things, when you're getting so many cases, you just kind of trust that the dentist already indicated that. That's just a second piece of advice. So over here, when you get to scan body type, if you're using the longer scan body, it's going to be a scan post. A shorter scan body, it's a tie base. This was a scan post, and you know, the rest is just indicating material and whatnot, so I think that's pretty self-explanatory. The veneering phase, the framework phase. Now we left off on scan post, and as you can see when you bring up this scan body up or scan body scan, you could see that these are the taller versions, and that's why scan body was indicated. Now if these were lower, you would indicate them as a tie base. Secondly, you always want to ensure that these notches line up. If these don't line up, because the block that you're milling these restorations in has a predetermined notch in it, already built within the block. So there's only one way that this crown's going to get milled, and if you have this misaligned, your notch isn't going to line up with what you have here in the scan, and the crown's going to go in crooked, and no one wants that. So please make sure that this notch is lined up with this notch. And as you can see, that was done here. Great job. Hope you don't mind me calling out your name. I'll probably ask you if it's okay to publish this video before publishing it. So let's move on. We go into, and we're gonna, everything here is typical, you know, whether you're doing a crown, a bridge, this is all gonna be the same. Gonna check occlusion, it's gonna take you into the model axis, gonna do that, blah, blah, blah. You're gonna get into trim model. And when you trim the model, you can trim it out if you want. It really doesn't matter. Then when you get to click scan body head, you're gonna always click, and I'm not gonna do any of these changes live. This is just a short video to kind of outline the process, because I've already got these things designed. They're already getting milled. No way I'm redesigning these. But I think you guys will get the idea, even without doing that. So we get to click scan body head. You're gonna always click the point of this pyramid, the very tip. You know, if you've heard otherwise and it's working for you, then click wherever you want. That's just what I do. I click on the very tip of the pyramid. And once that is complete, you're gonna move over to edit emergence line. Now this, my friends, is key. You gotta get this one right. And if you've done implants and for some reason your emergence isn't right, it's probably because you overlooked this portion. When you get to here, edit emergence line, always click use gingiva mask, because that is gonna line up the crown with exactly where the tissue is. Where you mark that line is where the crown is gonna meet the tissue and crown is gonna be exposed. So the goal here is to make an emergence line where the natural tooth would emerge from, or if you were to prep a natural tooth, where that margin would be if you were setting the margin at tissue level. So we got ours here, and another way to determine if you've got this marked right is look at the adjacent teeth and say there was a central here. We would be looking at it from the occlusal view and trying to get a picture of where that central emerges from. Now, luckily, with this case and this scan, you can almost outline where this tooth emerged from previously just by looking at it. And that's what we did here. Click to use gingiva mask. We marked those lines, did that for number 9 as well. And then once you get to set restoration axis, you can then see the emergence of both of them. And, you know, we're good. We are good. I like it. And then once you get here, this phase is so easy, and looking at this, that's not lined up exactly how it should be, but it will also be okay. It's just fine. But if it's red in any position, that means you need to readjust this arrow. Or in other words, this would be your set insertion axis portion whenever you're doing a crown. What you're doing is you're aligning where this hole should be, and the hole should be here. So what you're going to do is you're going to grab this arrow or move it from here, and you're going to line it just this way. Arrow, you want it going straight up and down with this red dashed line. And once you've got that, you get to go to the design phase. Ooh, great. Well, luckily you were able to see the final result beforehand, but this just recalculated everything. Oh well, we'll live. Let's go to restoration parameters. We're going to leave spacer the same, proximal contacts the same. Whenever I'm doing an anterior case, I don't adjust occlusal or dynamic contact strength. And that's just, I manually do that when we get into the design phase. As far as the minimal thickness, this is pretty much the only area you're going to touch up on with an anterior case, implant anterior case. Top layer. How thick do you want that? I set it to 600 and 600 microns, or in other words, 0.6 millimeters. That just means that that's going to be the thinnest point of the crown if you do interfere with that minimal thickness. If there's any blue showing through the crown, that means, okay, that area is going to be less than 0.6 millimeters in thickness. Now, I leave it really low, lower than the manufacturer of, in this case, Emax recommends, because if you do set that minimal thickness to, say, 1,000 or 1,200, which is what they recommend, your proposal is going to try and fit around that minimal thickness setting. So what ends up happening is when you do get a proposal, it's usually pretty bulky, or just, it looks like a wadded up gumball, in my opinion, when you leave that minimal thickness setting high and you get that proposal. It always comes out bulky, and that is not what we're trying to do here. When making a crown, the objective is make that crown look like it's a tooth, and the name of the game is matching natural teeth. And natural teeth wouldn't look so bulky in nature. I don't know, maybe elephants have, or giraffes or gorillas have big bulky teeth. Humans, however, do not. They're pretty dainty and fine in nature, and that's the name of the game. Cosmetic dentistry is just making teeth look like teeth in shape and in color. It just boils down to that. It's really as simple as that. And to get the proper shape, set that minimal thickness a little bit lower than the manufacturer recommends, and you're going to get a nice proposal. And that really is the objective of getting a good design with the CEREC system. With the CEREC system, the computer wants to give good proposals. You just have to set it up in a way to give you a good proposal, because the computer is going to do what you want it to do. And in the restoration parameters, the adjust morphology, and the positioning phase, that's going to determine your proposal. So if you want a good proposal, make sure you do everything right in these 3 phases before going into the edit element phase. One of those things is setting the minimal thickness a little bit lower, being on the risky side, but really you're still in control of the thickness. The idea is just to get a good proposal. So set that thing low. Low, baby. Low, low, low to the flow. 600 is good here. And that's that. You could even go to 400. Sometimes that is the case. Go to 400, do it. Just whatever you do, get a good proposal, and in the edit element phase, you can then adjust it to the desired thickness that you want the crown. Okay, bottom layer. Bottom layer, once you get here, if you're doing a screw retained crown, most of this is completely irrelevant. You don't need to mess with it at all unless you want to play with the gingival pressure. And it gives you a really nice, you know what, we're just going to design this thing. Let's just do it. You saw the final result in the beginning of the video, but let's just do it again. No one's going to get hurt. So let's just set and you could see, it gives you a great visual of how much pressure you're dealing with. If you've got it at 800, you can see there's going to be a lot of pressure. You've got a lot of pressure right here. We're not going to do that. And then you could see at anything negative, there's going to be no pressure at all. Now, what I typically do, I usually put it to like 150, little bit of pressure. The tissue is usually soft in nature, and it can withstand slight amounts of pressure. Shoulder width, this is gonna, it's just your shoulder width. You can see right here, we're adjusting it. Now, if you're dealing with a really small amount of space, I recommend setting the shoulder width as low as possible. Now, that's gonna give you feather edge margin, and if you are splitting this crown and your top layer is Emax, those margins are guaranteed to chip. They're gonna chip. So set the shoulder width to about 400 to 400 is even a little bit risky for me. And I'm a gambler. I like to gamble, not gamble. I like to take risks. I like to push the envelope, and I'm gonna do whatever it takes to make something look beautiful. And sometimes taking it down to 400, even that is, you may get some chipped margins. So let's set this to the shoulder width to 500, but we do have enough room in this case, so we'll set it to 700. Now, the minimal thickness, the radial thickness is just going to be, if you are splitting the crown again, and we actually are splitting these crowns, so we will dive into this. These are going to be milled in zirconia. I have no problem setting that to 400 microns, 0.4 millimeters. By the end of the day, between both of the layers that you're milling, you're going to have plenty of thickness to either mask that abutment or the tie base, or just have a nice long-lasting restoration. You're going to have plenty of thickness, but 400 will set it to that, and I feel comfortable with that. And we'll go to apply to similar restorations for both of these. Now, that's done. I hope that I explained the whole restoration parameters well enough for it to kind of register and be clear and concise. I'm trying to be as clear and concise as possible here. When we go into adjust morphology, I never really mess with this because I prefer biogeneric, and the system or software sets it as biogeneric by default. So unless you want to play with the anterior forms or you want to get some sort of shape from the tooth database, then you can play with this. But when you do play with those, the anterior forms or the tooth database right here, when you go into the edit element phase, it's going to disable the biogeneric variation tool, which that right there is the golden goose. You want that biogeneric variation tool enabled because there's so much control in terms of what you want the shape to look like. It helps with proposals tremendously. So you want to leave biogeneric variation enabled. So leave this at biogeneric when you get into the adjust morphology phase. This is going to be a good video. I like it. So we've gotten to the positioning phase, and this is going to play a huge part in how your proposals come out. Huge. More than any of the other two that we just touched up on. So when you are in this positioning phase, you're going to have two tools to play with: move and rotate, and scale. Now, when you're going to move and rotate the tooth, now these are already positioned from the previous design that I did, so I don't really want to toggle with that too much. There's really no need because they're already where I wanted them to be. And we are fitting them to fit within the natural teeth and to fit within the emergence of the tissue and the implant placement. And we did a good job with that. But let's get back to the tools. Move and rotate is going to allow you to adjust or move the tooth where you want it. Now, scale, which is another big one. Let's just leave one of these enabled. Okay. Now, scale is going to allow you to fit that tooth to the prep. And in order to get good proposals, you need to make sure that you're fitting this tooth in the positioning phase as well as you can to the prep, or getting it fitting as close as possible to where the crown's going to be. So say your prep margins are out here, and if you can see my cursor, say your prep margin is right out here, especially on the facial, not so much the lingual, but say it's out there on the facial, you're going to want to position that to fit that margin. You get what I'm saying? And you can move these in any direction, but you want to fit that tooth to the margin. And that's going to give you tremendous, tremendous proposals. When you can get this tooth or crown fitting as well as you can in this phase, when you go into the edit element phase, most of the time if it's fitting well, this doesn't even change when you get into the design phase. It looks the way you want it to look. And then from there, it's just, you're having fun. You're just making things look pretty. Hope that made sense. I can make another video touching up on that more. This isn't really a good case to kind of display all the things you can do in the positioning phase. So here we are. We've got our proposals, and they need work, definitely, but it's going to be so easy to make these look good. It's like most of the work is done. And that's the name of the game. You want this to be easy. You paid $120,000 for this system that you're using, CEREC. You want, after you make that sort of investment, you don't want to be putting much time into these things. That's the last thing you want. Now, that's why there's certain services that that I offer to you guys to kind of minimize the amount of time that you need to put into the system. You made the investment, and you want things out of sight, out of mind. You want crowns that are going to be easy to produce and go in beautifully. So, with that being said, sorry I got off on that rant, but we're going to just start designing this thing. And first things first, with every single design, we are going to use biogeneric variation, this golden goose right here. If you use any other tool before using biogeneric variation, all the adjustments that you made before using the biogeneric variation tool, they're going to just disappear. Because biogeneric variation, in a sense, is kind of reproposing things. But it's reproposing things in a way that you want them in terms of the shape and anatomy of the tooth. And right now you can see these are very bland looking. They're just not very aesthetic. So we're going to use biogeneric variation to get there. And you could also use biogeneric variation to recalculate a proposal. Say you get a proposal and you just don't like it. Oftentimes biogeneric variation will make it to where you do like it, and all you had to do is play with one tool, and now the tooth looks like a tooth and it doesn't look like a wadded up, chewed up gumball. So let's do it. And with centrals, biogeneric variation can give you some weird proposals. See, like this, to me, these are heavy contour lines. I mean, they look bulky. So, and when you do play with it, before you get to these kind of this tooth shape, it doesn't change much from where we were at originally. We were here originally, and now we're like here. But still, I do like that better than the original proposals. See, these are just heavy contour lines in my opinion. So we'll just stay in this range and go from there. Okay, so as you can see, like from my point of view, things already look great. A lot better than they did before, and all we did was play with biogeneric variation. Now, after biogeneric variation, the next tool you're going to use, and this is my step-by-step process, I'm giving it to you guys for free. And this is going to give you some great results if you follow this step-by-step process. So we've gone through biogeneric variation. We got the tooth, how we want it in terms of shape and anatomy. We are then, second step, let's get rid of these holes first, because we're going to split this anyways. We're going to go to move, and we're going to then reposition it again, because sometimes when you use biogeneric variation, even though we positioned the tooth before, it'll reposition it. So we're going to position these back to where we want them. Second step, reposition them. And I won't get too meticulous here because I want to keep this video short. It's already going on longer than I wanted. But I think you guys are going to find this video really helpful too. So I'm okay with putting in a little extra time. So we've repositioned them that direction. Now you can see they're canted. I don't know why the software does that, but it does. So we're going to straighten these up, bring this in a little bit, maybe shorten it a little bit. And the rest that we do, we can manually do with the shape tool. Now let's look at this from every angle. Every angle. I want to make sure things are dialed in from every angle. All right. And you could see that these laterals, this contour line, this distal contour line, the whole thing is kind of concave in shape. And so I'm not really trying to mimic that so much with these centrals, because at the end of the day, it'd be great if they even crown the laterals, but, excuse me, but we will get them to where everything's matching. And I like that, where they're positioned. So now we're just going to go into shape, and with implants, the very next thing you're going to do, take away this upper jaw and look at what we got here. Boom! What is that? That is what it looks like underneath the tissue. And this is just creating areas for bacteria to rest and host and have parties and whatnot. Let's reshape this. Let's make this nice, smooth, and kind of spherical shape. We're just going to smooth it out. Ovoid, I think that's a word you can use. But yeah, we're just going to kind of bring things out with the shape tool. And this is doing the bulk of the work here. Because right after this, we're going to use the smooth tool. And I'll display that after we... But what we're doing is we're just trying to get rid of the contrast, the shadows. Because underneath this tissue, we want things smooth, nice and round. And the shape tool, this is just the rough draft. Once we get to the smooth tool, we're going to refine it, and everything's going to look really nice. So as you can see, it's already like kind of rounding off. So after we've got that, and you can see the CJ right here, we're going to get rid of that as well. But after we round that off, we're going to go to form, we're going to go to smooth, and if we set this strength really high, it's going to take away a lot. It's going to be dramatic. Let's just do it. You can see for yourself. But things just go quick. And we want control. So we're going to undo that. And we're going to set this strength to about 27. That's going to allow enough control. And the size you pick, too, is also going to determine how much control you have. If you have a really large size, because what the smooth tool is doing, when you're actually smoothing it out, it's kind of just averaging out the level. So say you've got a really high point here and a really low point here, and you have your the size of the tool this large. What it's going to do is it's going to average this area out. So if we went in here with high strength and a really large tool, it's going to take things away even faster. And you can see like that's what it did. And that's just a really smooth, boring, round surface. We don't want that. We just want to smooth out this area under the tissue. So 20, it doesn't really matter. You don't need there's no math to it. Just whatever you feel is going to give you control. And then you could set the size to it. And then we're just going to go around and slowly make sure that everything under this tissue is rounded off. But you want to do this prior to making any other adjustments, because when you go to split this, it's going to give you a better proposal. And that's the name of the game, getting a good proposal. Because once you get a good proposal, everything is just downhill. It's really fun at that point. Because once you get a good proposal, you've got the groundwork, you've got a nice, clean, blank canvas, and all you got to do is draw a couple little trees and a sunset, and you've got $1 million painting. But when you start out with a canvas that just got thrown out of the trash and it's got dirt on it and snotty rags and tissues on it, it's going to be hard to make $1 million painting with that. So the name of the game is get a nice blank canvas that doesn't require much. In other words, a good proposal. We're just smoothing out this surface below the tissue. And we've done that, and it's good. And then you could kind of finish things up again with the shape tool, just to, like, you know, somewhat refine things, round it off even a little bit more. And by looking at the crown from different angles, you could see where there's areas of contrast, and that's just kind of where things aren't rounded off. Because the software kind of has like a little built-in light. You can see all these like little light reflections, and that's great because that's what it's going to look like when you put a light to the actual crown after it's milled. Okay, so that's good. Again, don't want to get too particular, which I can very easily do. I just want you guys to get the overall idea of what we're doing here. So you're then going to do the same thing on tooth number 8. Going to do the same exact thing, blah, 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 but we won't do that. I want to get this video over with. I want to keep you guys informed and entertained. Don't want things to get too boring. But another great tool to use is individual 4-directional in the shape tool. Using 4-directional is going to allow you so much more control than just by using 2-directional. Say you want to sharpen up this mesial and incisal edge area. You want to make this a little pointer. You want to bring it over. You just want to sharpen things up. Using the 2-directional tool, you can do it. But watch what happens when you use the 4-directional tool. And you want to bring this over and sharpen up this edge. Watch what happens. Just decrease the size. Grab an area kind of not on top of it, but close to it. And what you're going to do is you're going to bring all that shape to a point. See that? See how refined you can make things with the 4-directional tool? That's just one example. I use this thing for just about every design, 4-directional. And people often ask me, what do you use 4-directional for? I don't get it. You're using it for total control. You're able to manipulate a certain area of the crown in any direction. So say you've got this contour line, another great way to use it. You've got this contour line, this mesial contour line, and you don't like how angled it is, or you want to bring it tighter together. You want to bring both of the mesial contour lines in together. What you're going to do is you're going to hover right over it with the 4-directional and just bring it over. It's as simple as that. Just bring it over. Then you could go back in with the 2-directional and kind of refine things. But then, you know, the same way that we kind of rounded off the area underneath the tissue, we're going to do that for this like little CEJ area, just kind of where like a root would be, I guess. It's not all that appealing, so we'll get rid of that. And what you're going to do is you're going to take the shape tool and you're just going to do the bulk of the work. Look at it from this angle because that's where you're going to see the contrast. And then maybe make it a little bit smaller. And we've got the bulk work done. Then we're just going to smooth it out, or in other words, level out the playing field. See, when we use the smooth tool, it's just going to level out the surface. So we've got a high area here, we've got a low area here, and it goes back to a high area. So what the smooth tool is going to do is just level all that out. It's going to find the average height and just level it out. And then typically after I use the smooth tool, because it can be pretty aggressive, I'll go back in with the shape tool again and then reshape it. Just bring things back out or in where I want them. And I mean, we pretty much eliminated that. I would be more meticulous if I wasn't trying to just get the point across. But you can see what we've done there. So we're not going to play with tooth number 9. We hardly touched up on tooth. We're not going to play with tooth number 8. We hardly touched up on tooth number 9 is what I meant to say. And then, you know, say a crown's looking a little bulky. Here's another little trick. Just go to shape, go to anatomical, go to 2-directional, and just bring that baby in. Just bring that baby in, and certain areas will come in more than others. So then you go to, the individual tool, and you just refine it. And you just refine it. It's as simple as that. You can see it's like a little bit concave right there. Look at it from that angle. Bring it out. And then look at it from this angle. You can see it's a little bit concave right here. So just bring it out a little bit. There you go. That's just another little trick. But say we've got everything now exactly where we want it. I walked you guys through the steps, and you've used the shape tool, the smooth tool. You've got everything refined and exactly the way you want it. One little last touch you can do is go over to Sisal Variation. And this is by no means like a finished product. I just want to like state that again. This is just, I'm showing you guys how to use the tools. If I were to do this live, this would be a fairly longer video, much longer video. So anyways, when you're using the Incisal Variation tool, what I like to do first is set the strength to 100. And then you can get a really good idea of what the tool is going to do and how it's going to manipulate the crown. And you'll just go through the different variations, decide on a shape that you like. And I like to go with 3 sometimes, every now and then. It kind of like flattens things out, adds some more anatomy to the tooth. And then you're going to just click apply, and you're going to make it subtle. Now, this is just going to drive me nuts because it's not a good representation of the kind of work that I do. Again, it's just to show you guys how to use the tools. But then another little tool I like to use in this, or another variation, is number 5. And I make this really subtle, usually about 9. 7 to about 12 is the range I'll take the strength to with variation number 5. Gonna click apply, and then you go to 6. And now you've just added so much more depth, because when you set this one to 100, the only difference between 5 and 6 is the width of these horizontal lines, or the horizontal anatomy, how much space is in between them. So we've got it set to, we've already done 5, now we're gonna set it to 6 and do this one subtle as well. And it's just adding so much more depth. You're getting just different variations all put together, and by the end of it, you've got a really beautiful crown. That may be set a little bit too high. Then you just go to Form Tool, set the strength really low, and kind of just smooth it out slightly. All right. So you guys get the idea. We're only working on tooth number 9. We're going to go into, we didn't even do contacts. But then you're going to go into the edit multi-layer. And at this point, like, let's see if this abutment would work. You go to the top layer, and you've got minimal thickness issues. So let's just bring this down slightly. We're going to use scale. Most of what we're going to use when editing an abutment is scale, because we've already shaped the external aspect of the abutment. It's just now the internals that we're trying to fit to the crown. So we're going to use occlusal scale hole. And if you don't use scale hole, it's just going to grab a portion. So we've got that where we want it. Now we've got minimal thickness issues here. We're going to go to radial, and we're going to take away scale hole because we just want to pinpoint this area. Whoops. Go back to scale. There we go. We're just going to bring this out. And then to finish off this edge, go to shape, individual. And the software won't allow you to move certain things if it's going to create an undercut. So it won't just allow you to move this abutment in any direction. It's going to eliminate undercuts as well. So you're kind of restricted with the tools. And say you want to smooth this surface out, just smooth it out. Grab the smooth tool, smooth her out. But this is just about done. If we go to back to the veneer structure, minimal thickness isn't really an issue on the facial, and we can just bring things out here, especially, you know, given how much room there is. Then after that, because you've already set your contacts before splitting it, you don't have to touch anything. After the abutment is good to go, you're then free and clear to mill these things out. Now, I hope that you guys learned a good amount from this video. If you didn't and you want me to go more in depth in certain portion of the design phase, I'll definitely respond with a video of what you request. But this was a great outline. I'm pretty happy with this video. I'm gonna edit it and put it out there for you guys. Please comment. Please like it and subscribe it if you're watching this on YouTube. I always appreciate the feedback. So look forward to hearing from you guys. And I'll just talk to you next time.